I received a question regarding this problem, which is 8.1, number 15T in the study plan or in your homework set. So look in the top right corner and see if it's 8.1, number 15. All right, so let me click on View an Example. Oops, not help me solve this. That's not what I wanted at all. View an Example. There we go. Okay, so we have a simple random sample of size n equals 64 is obtained from a population with mu 77 and sigma equal to 24. Letter A is they want us to describe the distribution of x bar. Then they want us to find the probability that x bar is greater than 80.75, the probability that x bar is less than or equal to 70.25, and the probability that x bar is between 74.6 and 83.3. Now, all of this is based off of the central limit theorem. So let me go back to that in the notes real quickly and just point it out. The central limit theorem for the mean, that is, not for proportions. So it's an 8.1. And in the central limit theorem, it talks about how you have to have certain conditions met, which we do have. We have a simple random sample. We do not have a given population that it's normal, but they do give us a sample size that's large. And therefore, since we know these three things are true, we know that we have a shape, center, and spread according to these three bullet points right here. All right, so that's part one, is they want to know the shape. Well, it's normally distributed because n equals 64 is greater than 30. That part's done. The center would be the mean of the x bars. The mean of the x bars is equal to mu according to that formula on the central limit theorem. And then mu was given in the problem. It is 77. So there's that part. That's the center of your normal distribution. Then the spread for your normal distribution is sigma sub x bar, which, if you'll recall, is this formula, standard deviation divided by the square root of n, which is called the standard error. So the standard error is sigma sub x bar, which is sigma over the square root of n. Well, I know that the square root of n is the square root of 64, and sigma was given to us as 24. So that's 24 over the square root of 64. And I could use my calculator, or I could do that particular one in my head. There we go. So 24 divided by the square root, second square root, 64. And you get 3, because the square root of 64 is 8, and 24 divided by 8 is 3. So this is 3 here. All right, so now we have our shape, center, and spread. That means we're able to draw normal distributions for the next problems, and then use that normal distribution in order to find the probabilities that they are requesting. All right, so the first one we want is the probability that x bar is greater than 80.75. So let me draw you a picture of that real quickly. All right, there we have a picture. And you can see that I have 77 in the center. It's a normal distribution. The standard error is 3. Then I have 80.75 over here on the right. And I'm looking for, technically, what this area is over here on the right. Now I can see that Minitab thinks it's 0.1056, but of course we wouldn't know that. So we'll just put area question mark. Okay. All right, so that's what we're looking for. And we're going to find it using the calculator. So we're going to use normal CDF from the calculator. Now, normal CDF always goes the left to the right, the mean, and then the standard deviation, standard error. So the left-hand edge of what we shaded was 80.75. The right-hand edge is 1E99. Keep in mind that if you were doing this on an exam or whatever, you would be definitely drawing that picture just like that. So don't get in the habit of saying, oh, I won't need to draw a picture. Yes, you definitely will on your final exam, on any exam on this material. So you want to get in the habit of drawing a picture and appropriately scaling it and shading it, etc. All right, so I would want to take my calculator and I want to find normal CDF of these values. So let me grab the calculator and give you that screen. Okay, so clear all this out. Second distribution, number 2, normal CDF. You want to say 80.75, was that what it was? Yeah, 80.75. Then 1E99. E is above your comma. Then 77, and then 3. Paste. Enter. And you get 0.1056, just like Minitab thought it was. Oop, that's Minitab. You don't need to see that. All right. Hmm. Oh, rats. There we go. Got it. All right, that part's done. Now let's do it again, but let's have it be for less than or equal to 70.25. 72.25, of course, is going to be on the left. So I'm going to go draw that picture. I'll be right back. All right, there's the picture. You can see I have this left tail over here shaded because it's less than 70.25. So this is going to reverse our earlier use of the one E99, because before we used E99, capital E for block letter E, for positive infinity, but this time we want negative infinity. So it's negative 1 E99 and then 70.25, comma 77, comma 3. So let me go grab the calculator. Second distribution, number 2, normal CDF. We want negative 1 E99, 70.25, and then 77 and 3 are staying the same. And you get 0.0122. All right, now the last one wants 74.6 to 83.3. Now you can see I've already drawn that one and have it shaded and everything. So we're looking for that area in between. It's going to be a big size area, but the nice thing is we don't have to deal with the E99 business because we're not going off into either tail forever and ever. We're going from the left value of 74.6 to the right value of 83.3. So let me go back to normal CDF. Number 2 again. It was 74.6 to 80, oops, enter, 83.3. There we go. And I get 0.7703. And there we have it. That's how to find all 3 different probabilities. So this is a right tail probability, that's a left tail probability, and then this is kind of a central probability. Obviously the central one's the easiest one because it doesn't involve that whole E99 business. And I believe that's everything we need for this problem. Yep, that's all we need. If you want to click through it, you can see that it matches the answers I gave. So 0.0122 is right there, and 0.7702 right there. All right, we're all done with that question, and I hope that was helpful to you. I'll see you back here for more tutorials.